Okay, so this is the Leaving Certificate Higher Level Maths Paper 2 for 2018, and it's question 7. Now we have a section of a garden. Railing is shown here in this diagram. This section consists of 9 cylindrical bars. So these parts here are cylinders, labelled A to L along here, with a solid sphere attached to the centre of the top of each bar. So these circles here are actually spheres. The volume of each sphere from B to E is 1.75 times the volume of the previous sphere. So whatever volume this is, we multiply it by 1.75 to get the volume of this one, and so on. Now, first question then. The radius of sphere A is 3 centimeters. Find the sum of the volumes of the 5 spheres A, B, C, D, E. Give your answer correct to the nearest cubic centimeter. Okay, so we know anyway these are spheres, so we've got volume is equal to 4 over 3 pi r cubed anyway. Now the volume of the first sphere, sphere A here, is going to be 4 over 3 pi times 3 cubed, and when you work that out you get, well, let's leave it in terms of pi for the moment, 36 pi, and we're talking about centimeters here, so it's centimeters cubed for volume. Now we want the sum of, this is the volume of the first one here, we want the sum of the first 5 spheres. So what I'm going to do is, I know that this is a geometric sequence here of volumes because we have a term here which is 36 pi, and then we're multiplying that by 1.75 to get the next one, multiplying that volume by 1.75 to get the next one, and so on. So I'm going to do the sum here, the sum of the first 5 terms. So the sum of n terms is just a times, now I'm going to do or to the power of n minus 1, we'll see why in a second, or minus 1. So it can be 1 minus r to the power of n divided by 1 minus r, or it can be this way around here. Now we know that our first term in our sequence, in other words, a here is, let's say 36 pi. Now we know that r here is going to be 1.75. We're multiplying each of these volumes or each of these terms by 1.75. So what I'm going to do then is just do the sum of the first 5 terms. So that's going to be a, which is 36 pi, times, now the reason I put the r first here is because r is greater than 1. Usually if r is less than 1 you would reverse these two. Now r is 1.75 to the power of n, which is 5, subtract 1, divide by 1.75 minus 1. So this is all just kind of calculator work again, so all you got to do here is do this in bits and pieces. Try not to put it all into your calculator maybe in the one go. Maybe do the top line first and then the bottom and then do the division, but you get 2324.2388602. This is centimeters cubed when you add them. Now the question, go back and read the question again. The question says give your answer correct to the nearest cubic centimeter. So to the nearest cubic centimeter, this is 2324 centimeters cubed to the nearest cubic centimeter. Okay, so that's part A. Let's have a look at part B here. Now in this part we're talking about surface area of the spheres, and surface area of spheres is just 4 pi r squared. It's like 4 circles, if you like, 4 areas of circles. The surface area of the sphere E can be taken to be 503 centimeters squared. So sphere E here is this one here. It's the tallest one, if you like, the biggest sphere, and it's the one in the middle. So we have 1, 2, 3, 4, 5. It's the 5th one. So the surface area here of E is, so the surface area of E is 503 centimeters squared. Okay, the height of the railing at E, the sum of the heights of bar E and sphere E, is 1.2 meters. So they give us a diagram here. So the bar here plus the sphere is 1.2 meters. Find the height of the bar E in centimeters, correct to one decimal place. So we've got to find this height here. Okay, so let's have a look. What we're going to do first is, what we're actually going to do is find the radius of this sphere here. So if we could find this distance here, the radius here, all we got to do then is double it and subtract from 1.2, and that will give us our height here, the height of the cylinder here, if you like. So what have we got? We've got the surface area of this particular sphere. So let's see, we can just put that into our formula here. 503 is going to be equal to 4 pi times r squared. Now we have everything in this equation except for r, and that's exactly what we were wanting. We want to try and find r here. So r then is just going to be 503 divided by 4 pi. So the radius, well that's the radius squared. So what we got to do is square root that, and what you get is r is equal to, now I've done this to 4 decimal places, it goes on longer than that, but remember we only need 1 decimal place at the very end, so don't really round to 1 decimal place until the very end, because you just accumulate errors. So I'm doing this to 4 decimal places, so 6.3267, 6.3267, and so on. This is in centimeters. So this is the radius of our sphere here, so that implies the diameter is going to be equal to double this. So when you double 6.3267, you get 12.653,653,453, and so on. Now, so we have our diameter. In other words, we have the distance from here to here. So all we've got to do is subtract that from 1.2, and that will give us the height of bar E. And we've got to just do that to 1 decimal place. So that means then that the bar height is just going to be equal to 1.2 meters. Now remember, this is in centimeters here, so I'm going to just change 1.2 meters to 120 centimeters minus 12.653453, and that will give me 107.3465, and so on, which is going to be equal to 1 decimal place 107.3 centimeters. This is to 1 decimal place, which is what we were asked for here. Okay, so that's part 1. Let's have a look at part 2 here. We have the radius of each bar is 1 centimeter. Now these bars are cylinders, remember. The volume of bar A is 71.3 pi centimeters cubed. The heights of bar A, B, C, D and E form an arithmetic sequence. So this time we're adding a number to each height to get the next height, and so on. Find in centimeters the height of each bar. So you've got to find the height of each bar. Now, the volume of bar A, by the way, we're talking about the volumes of cylinders here, so let me just write that down. The volume of a cylinder is pi r squared, which is the circle at the bottom times the height of the cylinder. The area of the area of the circle at the bottom multiplied by the height. Okay, so we know that the radius of each bar, so r is going to be equal to 1 centimeter. Now the volume of bar A, so the volume of bar A is 71.3 pi centimeters cubed. Okay, so we have the volume of bar A, so let's just stick that into our formula here. So we have 71.3 pi is going to be equal to pi times the radius of bar A, which is 1. So it's just going to be 1 squared times height. So we can find the height now of the first bar, bar A. So 1 squared here is just 1, so we've got pi times h. So in other words, h here is just going to be equal to, well, in actual fact, we can divide across by pi, so that will disappear, and we just end up with h is equal to 71.3 centimeters. 71.3 centimeters. This is the height of A. Now, let's have a look then. What have we got to do here? Find in centimeters the height of each bar. So we know we've got 5 bars to look at. We're looking at 1, 2, 3, 4, 5, A, B, C, D, and E, and they form an arithmetic sequence. So we have bar A here is 71.3 centimeters. We don't know 2, we don't know 3, we don't know 4, but 1, 2, 3, 4, 5 here. From part 1 we worked out the bar height of E, and that was 107.3, 107.3 centimeters. So this is, if you like, term 1, term 2, this is term 1, this will be term 2 here, this will be term 3, this will be term 4, this will be term 5 of our arithmetic sequence. Now we've got to find, in order to find these heights here, the other heights of the other bars, B, C, and D, we've got to really work out what the common difference is. Remember, it's an arithmetic sequence. So if we know what to add to this, we can get this one. If we know what to add to this, which will be the same number, we get to this, and so on. We have a common difference. So let's have a look. Now, there are a couple of ways of doing this, but let's do the formulaic way first of all. We know that Tn in an arithmetic sequence is equal to A plus n minus 1 times D. Now, we know that term 5 here, term 5 is equal to 107.3. So in other words, 107.3 is going to be equal to A, which is the first term, 71.3, plus n minus 1. Well, our n is 5 because we're looking at T5, so n minus 1 is 4 times D. So we can work out what D is here, a common difference. So let's have a look. 107.3, I'm going to bring this over here and subtract it from both sides, and what you get is 36. You get 36 here. So we're going to get 36 here is equal to 4D. So that will give me D here is just equal to 9 centimeters. So in other words, we're adding 9 centimeters each time here to get the next one. The other way of doing this, by the way, is just simply to take 107.3, subtract 71.3, and that will give you 36. It's kind of the same thing that we've done here. Now you've got 4 terms down to the T1 here, so you're just going to take 36, you're going to divide by 4, and that will give you your 9. If you can spot that immediately, then you'll get there a little bit quicker. This is the formulaic way of doing it, if you like. Okay, so what we're going to do then is just add 9 to each term. Let's do it down at the end here. We know that bar, let's say bar, these are the bars, and these are the heights. So bar A we know is 71.3. So we're going to write down bar B. Well, bar B we're just going to add 9 to it. So that will give us 71 plus 9 is 80.3. So we're going to get 80.3 here. This is in centimeters. Bar C, so we're just going to add 9 to that. So that's going to give me 89.3 centimeters. bar D then, add 9 to this, that will give me 98.3 centimeters, and finally we know bar E is 107.3. Okay, so that's it. That's part 2. I think that's all we were asked to do here. Find in centimeters the height of each bar. We've done that. These are the bar heights here. Okay, part C then. Now there's a wall on each side of the section of railings as shown in the diagram below, which is not drawn to scale. The distance from wall to wall is 1.5 meters. The distance from wall to bar A is 20 centimeters. All these dimensions are in here, and similarly from the other wall, so there's 20 centimeters here as well. The radius of each bar is 1 centimeter. So in other words, the thickness of each of these bars here is 2 centimeters. So you've got a 2 centimeters here, 2, 2, 2, 2, all the way along here. The gap between each bar is identical. So these gaps, these white gaps in here, are all identical. Find the size of this gap. Okay, so this again reasonably straightforward, reasonably short anyway. We're going to take the 1.5 and we're going to subtract the 40 anyway. We've got 20 here and 20 here. So we're going to take 1.5 meters, or let's convert that actually to centimeters because that's what we're dealing with. So it's 150 centimeters from here to here. We're going to subtract 40 centimeters anyway because we're not going to include that in our calculations. Calculations to find these gaps here. So we need the distance between this point here and this point here. So when you subtract here, you get 110 centimeters. So we know the distance between here and the outside of this bar here is 110 centimeters. Now we've also got these other dimensions here. We've got 2 centimeters here, 2 centimeters here, 2 centimeters here, and so on. Many of those 2 centimeters have we got? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's 2 9s, which is 18. So we've got 18 centimeters here as well, which we don't really need. So it's we got to subtract 18 centimeters here. That'll give me 92 centimeters. So the white areas here between the bars add up to 92 centimeters. Just the white areas in between the bars. So how many gaps are there? Well, there are 1, 2, 3, 4, 5, 6, 7, 8. So we're going to take 92 centimeters and we're going to divide it by 8, and that will give me 11.5 centimeters. And this is the gap size between each bar. Okay, so that's it for C. Okay, last part then, let's have a look at D. Now we have the sphere on bar A and the sphere on bar B are to be joined by a straight rod as shown. So this is the first railing the first cylinder and sphere. This is the second cylinder and sphere, and they're going to weld a rod here between the two in the diagram below, which is not drawn to scale again. Find the length of the shortest rod that will join sphere A to sphere B. Give your answer in centimeters, correct to 1 decimal place. Now, so we've got to find this length here, in other words. Now they've kind of given us a hint here because they've drawn a right angle triangle here. So I suspect what we're going to have to do here is use Pythagoras' theorem, or maybe sine cos tan, but I suspect because we don't have any angles, we're not given any angles in this question, it's going to be Pythagoras' theorem. So in other words, if we can find this distance here from the center of this sphere to the center of this cylinder, and the distance from here up to here, we can work out this radius here. We know this radius here is 3. We can just put in x here for the rod length and then use Pythagoras' theorem to work out what x would be. So let's have a go at all of that. Okay, so first thing we're going to do is look at the volume of sphere A. is 36 pi centimeters cubed. We worked that out at the beginning. Now the volume then of B, sphere B, is going to be 36 pi multiplied by 1.75. Remember, the spheres go up in geometric sequence. We're multiplying the volume of each sphere by 1.75 to get the volume of the next sphere. We were told that at the very beginning. So that gives me 63 pi centimeters cubed. So this is the volume of sphere B. Why did I do that? Because I want to try and work out the radius here, this distance here, the radius of sphere B. So let's work out that out. Well, we know that 63 pi then is going to be equal to 4 over 3 pi r cubed. This is the volume of any sphere. So we have everything in this equation here except for r, so I can work out this radius here. So let's see, first of all I've got a pi on both sides, so I'm just going to divide across by pi. Next thing I'm going to do then is multiply across by 3 and then divide by 4. So that will give me r cubed. I've got to multiply across by 3 and then divide by this 4. Okay, so what that gives me is 47.25. That gives me 47.25, and finally then I've got to get the cubed root of both sides. That gives me now again, look, we're asked to give our answer here to correct one decimal place, so I'm going to do a few decimal places here. So I'm going to do 3.615213. So that's 1, 2, 3, 4, 5. I've done 6 decimal places here. So that's our distance here. Okay, so let me just draw this right angle triangle here, just to give you an idea of what we're talking about here. So I'll draw it quite big. Okay, so there's our right angle triangle, and here's our right angle here, so that's this corner here. So this here is broken up into three parts actually. So this here is the radius of our first sphere, and we know that that's actually 3 centimeters. We've just worked out that this one here is 3.615213 centimeters from here to here, and this is the distance here we want to work out. I'm going to call that x, the distance from here to here. This is our rod length that connects the two spheres. Okay, so the other thing we got to work out then is the height here and this length here. Okay, so how are we going to do that? Well, let's have a look. We know that the distance from, let me just do this over here, the distance from here to here, in other words the rod height differences, we know that is 9 centimeters, because we just worked out in the previous section here, we worked out that where was it, back here, that the heights go up, the cylinder heights or the bar heights go up by 9 centimeters each time. So I know here that the distance between here, the top of this rod here, this cylinder I should say, and the top of this cylinder here, that's going to be 9 centimeters. 9 centimeters. Now I'm looking for the distance between here and here first of all, so I know that's going to be 6 centimeters, so that's going to be 6 centimeters from here to here. All I've done is taken away the radius. I know this radius here is 3 centimeters, so I've taken away the radius from 9, that's given me 6 from here to here. All I've got to do is add that to the radius of this sphere here, which I've just worked out as 3.615. So in other words, this height here is going to be 6 centimeters plus the radius, this radius here, which is 3.615213 centimeters. So it's 9.615213. So we have worked out our height here. Now what about this distance across here? Well, we know that the the gap here, I think we worked that out at the very beginning. Oh no, we worked it out in part C here, I think. In part C. If we go back up here to part C, we worked out the gap. The gap between each bar here is 11.5 centimeters. So the gap in the white space here, from the edge of this, the right edge of this, to the left edge of this cylinder here, is 11.5 centimeters. So how does that help us? Well, we have this distance here is 11.5 centimeters. That's from here to here. We know that the radius of each of these cylinders is 1 centimeter. So what I've got to do is to get to the center of this cylinder, which is where the center of the sphere is, I've got to add 1 to this on this side, and I've also got to get to the center here. So I'm getting to the center of each of these. So I've got to add 1 on this side, add 1 on this side. So basically I'm adding 2 centimeters to 11.5. So that gives me 13.5 centimeters. Okay, so now I have all the information I need here. All I'm going to do now is Pythagoras' theorem. So what I'm going to do here is take the hypotenuse first. So the hypotenuse is 3 centimeters plus 3.6 and so on centimeters, this plus this. That's going to be 6.615213. I'm going to square that. Oh, sorry, I've got to actually add the x as well. So I've got to add the x here, and I've got to square that. So I've taken this entire side, these 3 added, in other words, and I'm squaring it. So that's my hypotenuse squared. That's going to be equal to 13.5 squared plus this here is 6 plus 3, which is 9.615213. Okay, and that's going to be squared. Okay, so now all I've got to do is solve for x here, solve for x. So on the left hand side here I get 6.615213 plus x all squared. Now on the right hand side here you got to square this, you got to square this and add them. Again, that's just calculator work. So what you get when you do that is 274.7119 365. Okay, so what I'm going to do now is get the square root of both sides. So in other words, 6.615213 plus x. So I'm square rooting this side here, and I'm going to square root this side here. That gives me 16.57, 4436, 443623. Okay, last step then. We got to work out what x is, our rod length. So I've got to subtract 6.61523 from both sides. That gives me, let's see, 9.9592, 9.9592, and so on. This is centimeters. So this is our rod length here, our rod length. What does the question actually ask us to do? Find the length of the shortest rod that will join sphere A to sphere B. So we've done that. We found this distance here. Give your answer in centimeters correct to 1 decimal place. Okay, so to 1 decimal place here. So that means x is going to be equal to, well, you've got to round. This is going to round to 9, this is going to round to 6, this is going to round to 10. So in other words, and this is going to round this up to 10. So it's going to be 10.0 centimeters to 1 decimal place. And that's it. That's this length here, or it's the shortest rod that will join these two spheres here. It's going to be 10 centimeters, and you can check that. You know, you can do Pythagoras' theorem by putting in 10 here, or even putting in 9.952 here, adding the 3, adding this length here, and just trying it, see does it work. But it should do. It does in fact work. So that's it for this question.